Hello friends, today we'll solve the signal and system problems of GATE 2023 Electronics and Communication paper. So this is the first question. It is telling us that consider a system with input xt and output yt is equal to x times e raised to power t. So system is whether causal, non-causal or time variant or time invariant. So to check causality it is very easy, just put three values like y at t is equal to -2, y at t is equal to 0 and at t is equal to 2. So at t is equal to -2 it is x times x into e raised to power -2 and then x e raised to power 0 and at x e raised to 2. So this is y0 is equal to x1. So basically the input at t is output at t is equal to 0 is demanding the future input value at t is equal to 1. Okay, so to find y0 we need x1. Okay, so basically present output is depending on future input values, so it is a non-causal system. Similarly here also you can see that x e square is 7.38, so output at t is equal to 2 is demanding input at t is equal to 7.3. So again present output is depending on future input, so it's a non-causal system. And to check time variant or time invariant, we will use this simple test that time invariant means delay in input by t node is equal to same delay in output by t node. So delay in input by t node means like we write it like this, and this is equal to x raised to power t minus t node. We simply introduce minus t node inside the bracket, but delay in output by t node means we replace each t by t node. So yt minus t node is x e raised to power t minus t node, which is basically x of e raised to power t times e raised to power minus t node. So clearly this thing is not equal to this thing, so it's a time varying system. Okay, or for the time invariant or not, you can also use this fact that if there is any disturbance with t inside the bracket, then it is a time varying system. For example, even if we introduce just x of 2t, then you can see that delay in input by t node is x of 2t minus t node, but delay in output will be equal to x of 2, and then this entire t will be replaced by t minus t node, so 2t minus 2t node, so clearly 1 is not equal to 2, so it is time varying. Okay, so all such types of cases like x of e to power t, x of ln t, x of sin t, x of t square, x of 2t, all these make the system time varying. Okay, so the correct answer is it is a non-causal and time varying system. Okay, second question is on the signal type and spectral characteristic, okay, in Fourier domain. So four types of Fourier transform we know: continuous time Fourier transform, continuous time Fourier series, discrete time Fourier transform, discrete time Fourier series. So how they relate with each other? So we just need to know the simple fact that if the signal is discrete in one domain, then it will be periodic in other domain. Okay, so discrete in one domain means periodic in other domain, and periodic in one domain means discrete in other domain. For example, like sampling. So in sampling we have a discrete time signal. When you see its spectrum, then it is periodic. Okay, periodic samples appear the same continuous signal. And if you take the opposite of this, so discrete का उल्टा हो गया continuous. So if continuous in one domain means aperiodic in other domain. For example, like Fourier transform. So for Fourier transform, xt is continuous, so spectrum is aperiodic. Okay, so similarly aperiodic in time domains means continuous in frequency domain. So these are like both way valid. So first is continuous and aperiodic. So continuous का हो जाएगा aperiodic and aperiodic का continuous. So basically continuous aperiodic का aperiodic continuous. So this is the case of continuous time Fourier transform, where the signal in time domain is continuous and aperiodic, and the spectrum is also aperiodic and continuous. For example, rect of t has a spectrum as sync t, which is aperiodic and continuous, and rect t is also aperiodic and continuous. Okay, similarly like triangular function has a spectrum as sinc square, which is again aperiodic and continuous. B is continuous and aperiodic, so signal has to be continuous and it has to be periodic. So this is the case of continuous time Fourier series. So here the spectrum will be aperiodic, continuous ka aperiodic, okay, continuous ka aperiodic and periodic ka discrete. So this is the case of continuous time Fourier series. So you can see that for continuous time periodic signals, the spectrum is aperiodic and discrete in nature, as you can see in continuous in Fourier series. Okay. Similarly, discrete ka periodic, aperiodic ka continuous. So this is the case of DTFT. Okay. So in discrete time Fourier transform, the signals are aperiodic and discrete, and their spectrum is therefore periodic and continuous. So after each period, the spectrum जो है repeat करता है. Discrete and periodic, if the signal is discrete and periodic in time domain, then discrete ka periodic and periodic ka discrete. So this is the case of discrete time Fourier series. Okay. So for discrete time Fourier series, the spectrum is periodic and discrete. So basically the correct answer is B. So you just remember this one fact and then you take the opposite. So discrete ka continuous, periodic ka aperiodic, and you can solve all of them. Okay. So discrete in one domain means periodic in other domain, for example like sampling, and then you can remember all of them. Third question is on convolution property. It is saying that let x1t is equal to ut plus 1.5 minus ut minus 1.5 and x2t is shown in the figure below. So for yt is equal to x1t convolution x2t, and then this area under yt will be, okay. So x1t is ut plus 1.5, so this is ut 1.5, then minus of ut minus 1.5, so this is t minus 1.5. Now when we subtract them, so this is like 0 minus 0, so this is 0, and here also it is like 1 minus 1, so it is again 0, but between minus 1.5 and 1.5 this is 1, okay, minus 0, so this part is 1. So this is basically a rectangular function, okay, rectangular pulse of width 3, and this signal x2t is given to us. Now we need to find, we do not need to find the y2t, that is the result yt, result of the convolution, but area under the result of convolution. So here we will use the area property of continuous time convolution, that only area of output signal is asked, therefore we will use area property, which is that area of output signal yt is nothing but area of x1t times area of x2t. So if you take product of both the areas of input signal, then we can get the output area, the convolution signal. Okay. So area of yt is nothing but product of these two areas. So this area, this is a rectangle, so area will be length into breadth, so 3 into 1 3, and area of this thing will be like, this is rectangular of width 2 and height 2, so 2, okay, 2 into 1, and this is impulse, so impulse has area as 1 and this impulse has area 2. Okay, so this thing is not the height but the area of the impulse. This shows always the area under the impulse. So this is 2, so 1 plus 2 into 1 plus 2, so this is 5. So area of this signal is 3, this signal is 5, so when we will convolve them, the area of the output signal will be 5 into 3, which is 15. So correct answer is 15. This is a question on discrete time Fourier transform. It is saying that let a input signal x1 xn have discrete time Fourier transform x e j omega is equal to 1 minus e raised to power minus j omega plus 2 e raised to power minus 3 j omega passed through an LTI system. The frequency response of the LTI system is this, then the output yn of the system is. So basically the frequency response of the LTI system is given, input सिग्नल जो उसका फोरियर ट्रांसफॉर्म आपको DTFT दिया हुआ है, एंड वी नीड टू फाइंड द आउटपुट yn इन टाइम डोमेन. ओके, सो बेसिकली दिस इज द केस हियर that input is given in inputs DTFT is given, and frequency response of the LTI system, discrete time LTI system is given. We need to find the output yn, not y omega. Okay, so this is just based on the formula. If you know the formula of DTFT, which is x omega is equal to n is equal to minus infinity to plus infinity xn e raised to power minus j omega n. So if you expand it, you get it like something like it will go here also. So x minus 2 e raised to power j omega 2 for n is equal to minus 2. Okay, for n is equal to minus 1, it will be x minus 1 e raised to power j omega 1 plus x0 plus x1 e raised to power j omega plus x2 e raised to power minus 2 j omega. So for like n is equal to 3, it will be x3 e raised to power minus j omega 3 and so on. Okay, so on comparing this thing with this, you can clearly see that this part is x0 because it has no complex exponential term with it. Now this is e raised to power minus j omega, so e raised to power minus this, so this is x1, so x1 is basically minus 1. Similarly x2 is 0 and x3 is e raised to power minus 3 j omega, so this is coefficient is x3, so x3 is 2. Similarly this part is x0 1 and this part is x1 is 0, okay, because this coefficient is not there. And similarly this part is x2, so x2 is basically minus half. So now we know xn, now we know hn, so we can convolve them in time domain to get yn using tabular method. So xn is 1 minus 102, okay, 1 minus 102, and hn is 1 0 minus half. Okay, hn is 1 0 minus half. So simply take the convolution using tabular method. So 1 into 1 1, 1 into 0 0, 1 into minus half, then minus half into 1 is minus half, then minus half into 0 0, then minus half into minus half is half, and 0 into all this is 0, and then 2 into 1, 2 into 0, and 2 into minus half is minus 1. Now I simply add them diagonally. So this is 1, this is minus 1, this is minus half, and this is 2 and half is 2.5, 5 by 2, this is 0, this is minus 1. Now to locate the origin, we see where they are meeting. To here the signal is origin here, okay, because this is x0, this is x0, so they are meeting at this point, so this is the origin. So this diagonal value is giving this, so this part is n is equal to 0, so this is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, and n is equal to 5. So now simply need to write it using impulses. So it will be 1 times delta n, then it will be minus 1 times delta n minus 1, then it will be minus half times delta n minus 2, then it will be 5 by 2 plus 5 by 2 times delta n minus 3 plus 0 times delta n minus 4, and then minus 1 times delta n minus 5. So this, when I look into the options, this part is 0, so this is option number C. Okay, so again easy question, just formula based. Another question is on discrete time Fourier series. It is saying that consider a discrete time periodic signal period n is equal to 5, okay, and let the discrete time Fourier series represented by xn is equal to this formula. It is ak e raised to power j k 2 pi n by 5, where a0, a1, a2, a3, a4 are given. So sum, we need to find the value of the sum n is equal to 0 to 4 xn sin 4 pi n by 5. So here we need to see one thing, that this thing is xn sin 4 pi n by 5, n is equal to 0 to 4, and the formula for discrete time Fourier series coefficient ak is 1 by n is equal to 0 to n minus 1 xn e raised to power minus j k omega node n, where omega node is 2 pi by n, where which is the n is the period of the xn, which is 5, so 2 pi by 5. So ak formula here is this. Okay, so if you look at these two formula, you can see that these are very similar. N is equal to 0 to 4, n is equal to 0 to 4 xn, and then I can break this sign into these two complex exponential, and therefore I can write it as 5 times ak. Okay, so that's all we need to do here. So n is equal to 0 for xn sin 4 pi n by 5 is equal to n is equal to 0 to 4 xn, and then I will use this as e ki power j theta minus e ki power minus j theta upon 2j form, so I will get this thing. Okay, and now I multiply pi, take 1 by 2j outside, so this is n is equal to 0 to 4 xn e raised to power minus j. Now I'm trying to convert it into this form using appropriate k value. So it is, for k equal to minus 2 I am getting this thing, and for k is equal to 2 I am getting this thing. Okay, so this thing is nothing but 5 times a minus 2, and this thing is nothing but 5 times a2. Okay, So you can now clearly see that this can be written it like this: e की power minus j minus 2 2 pi by 5n and e की power minus j 2 times 2 pi by 5n. So this is k equal to 2, this is k equal to minus 2. So basically this is 1 upon 2j 5 a minus 2 minus 5 a2. Okay. Now we are not given a minus 2, we are given like a0 to a4, but discrete time Fourier series coefficients are periodic in nature. Okay, so ak is ak plus n. So a minus 2 is nothing but a5 plus minus 2, which is a3. Okay, so a minus 2 is nothing but a3, and a3 value is given to us. Okay, a3 value is minus 2j. So this is minus 2j. So 1 upon 2j, 5 times minus 2j minus 5 times a2 value is 2j. So basically it is minus 10. Okay, so final answer is minus 10. So we just need to convert the discrete time Fourier series coefficient formula into this. So we just need to relate them to, and it's done. Okay. So again a formula based question. This one is on modulation property. It is saying that that x1t and x2t will be two band limited signal having bandwidth b is equal to 4.2 10 to the power 3 radian per second each. In the figure below, the Nyquist sampling frequency in the radian per second of sample yt is. So first we need to find sample yt, and then we need to find it Nyquist frequency. Okay. So both are band limited and having bandwidth 4.2 10 to the power 3 radian per second. So let first signal have spectrum like this and second have spectrum like this. Okay, one is rect, another tri. So this is like bandwidth is only for positive frequency. So this distance is 4.2 10 to the power 3 radian per second. This is omega, this is x1 omega, and let this amplitude be a1. Okay, and then let this amplitude be a2, and this again the bandwidth is same, both signals same bandwidth. So this will also be 4.2 10 to the power 3 radian per second. Now they are fed into a multiplier. Okay, so after modulation property, you know that the signal will be shifted to this side and this side by this amount. Okay, you know the modulation property, right? So by modulation property, this signal will shift this side, left side and right side, and amplitude will become half. Okay, so the amplitude will become half, and this signal, the center will shift from 0 to this part. So 0 to it will now shift from 4 pi into 10 to the power 3 radian per second, and therefore this part will shift to 8 pi into 10 to the power 3. Similarly this side also it will shift, so it will be like this. Now when this signal is fed into modulator, then it will be shifted to this frequency from 0. So this will be like 12 pi into 10 to the power 3 radian per second. So this is a 4 16 pi into 10 to the power 3 radian per second. This will be 8 pi into 10 to the power 3 radian per second. Okay, and this part is also shifted in the negative part, so here it will be like that. Now they both are added, so by linearity the spectrum will be like this. So from minus 8 pi to 8 pi this part will come, and from 8 pi to 16 pi this part is come. Now we need to find the Nyquist frequency of this signal. So y omega is like this. So Nyquist sampling frequency is 2 times the maximum frequency present in the signal. So since maximum frequency present in the signal is 16 pi into 10 to the power 3, so into 2, so it will be 32 pi into 10 to the power 3 radian per second. Because whenever we add two signal x1t and x2t, then the maximum frequency component is nothing but maximum of omega max 1 of this and omega max 2. Okay, so here you can see that the maximum frequency component 16 pi into 10 to the power 3. So the maximum frequency component overall signal yt will be also this, and therefore when you multiply it by 2, then we get the Nyquist sampling frequency, because Nyquist sampling frequency is nothing but 2 times f max. Okay, another signal question on modulation. It is saying that let MT be a strictly band limited signal with bandwidth b and energy E. Assuming omega naught is equal to 10b, the energy in the signal MT cos omega naught t is. So here you can see that that MT has a spectrum m omega and energy E. Okay, then MT cos omega naught t will have the spectrum as m of omega minus 10b plus m of omega plus 10b by 2. So it will be shifted to 10b on both sides. So 0 to it will be shifted to 10b, and 1b will be shifted to 11b, and minus b will be shifted to and similarly on negative side also it will be shifted to minus 10b, so it will be from minus 9b to minus 11b. Now you can see that this signal has energy E, then since the amplitude is halved, okay, because of this modulation property, so this is the modulation property. So energy, for energy formula we know that in energy formula we always integrate from minus infinity to infinity, so we need to calculate energy of both of them. Okay, now since the amplitude is halved, you know that if xt has energy, then k time xt has energy k square E. So amplitude is half, so energy will be half square E, and this will be half square E, because this energy was initially E only, so it will be half square E plus half square E, so it is E by 4 plus E by 4, so E by 2, so overall energy is halved. Okay, or what you can do is like let mt has Fourier transform this. Okay, from minus b to b it's band limited, so energy of mt will be 1 upon 2 pi using Parseval theorem, minus infinity to infinity m omega square d omega. So this is 1 upon 2 pi minus b to b. Okay, and then amplitude is 1, so 1 square d omega. So this is basically 1 upon 2 pi, and omega from b to minus b is b minus of minus b, so which is b by pi. Now when I apply modulation property, I get it like this. So the spectrum is shifted on both the side by 10b. Okay, so now energy of this signal is again by Parseval relation 1 upon 2 pi minus infinity to infinity y omega square d omega, so which is 1 upon 2 pi, and then this part is minus 11b to 9b, and then this part is 1 by 2, so 1 by 2 ka square, so 1 by 4 d omega plus 9b to 11b 1 by 4 d omega. So again it is like 1 upon 2 pi and then 1 by 4 taken outside, so this is minus 9b plus 11b, so 2b, and then this is 11b minus 9b, so 2b, so again we get b upon 2 pi. So originally I was getting b upon pi, now I'm getting b upon 2 pi, so energy is halved. Okay, so correct answer is energy is basically E by 2. Okay, another question is on Fourier transform of Gaussian function. So it is saying that the Fourier transform x omega of xt is equal to e power minus t square is. So this is formula based question, that e raised to power minus a t square has Fourier transform under root pi by a e raised to power minus omega square by 4a. So here a is 1, so it will be under root pi e raised to power minus omega square by 4. Okay, so the Fourier transform preserves the Gaussian shape, just scaled in amplitude and spread in frequency. So only amplitude and frequency are like little bit changed, but the shape is intact. Okay, if you want to see the derivation in simple way, then you need to remember this formula, that minus infinity to infinity e raised to power minus ax square bx dx is under root pi by a e raised to power plus b square by 4a. Okay, this you remember, then it will be helpful. So now when I take the Fourier transform, then it will be e raised to power minus t square e power minus j omega t dt, and now here a is 1 and b is minus j omega. Okay, and therefore directly I get under root pi by a e raised to power plus b square, which is minus j omega square by 4, so which is under root pi e raised to power minus omega square by 4. So this integration is very important. Another important thing you can see it here, that if you write e raised to power minus j omega t using this cos theta plus j sin theta as like this, and this integral can be divided into two parts, e की power minus t square cos omega t dt minus I times e raised to power minus t square sin omega t dt. Now this is odd function sin, this is even function because Gaussian shape is even. Okay, so even into odd is odd, so odd का integration from minus infinity to infinity is 0, so we are left with only this integral. So this integral will also give us the same result. So minus infinity to infinity e की power minus a t square cos omega t dt is also under root pi by a e raised to power minus omega square by 4a. So both will result in same result. Okay, so this is also easily derivable from this and can be asked in future. Last question is on Fourier transform. It is saying that let xt is equal to 10 cos 10.5 omega be passed through an LTI system having impulse response this the output of the system is. So we need to write everything in terms of frequency domain. So let's find out what is this sine omega t upon pi t square. So we know that sine 80 by pi t has Fourier transform minus pi by 2 pi by a, and this is rectangular function. Okay, so now here it is a product of sine 80 upon pi t square, so it is sine 80 upon pi t into sine 80 upon pi t. Now multiplication of two signal in time domain give us 1 upon 2 pi times x1 omega convolution x2 omega. Okay, so we know the convolution of two rect function is a triangular function, and using this width property it will be from minus 2a to plus 2a. Okay, this 1 upon 2 pi factor will come, and to find height I'm using this 1 into 1 from minus a to a dt. This is giving 2a, so 2a by 2 pi is a by pi. So here it is sine w t by pi t. Okay, sine w t by pi t, so here it will be w by pi. So basically this is w by pi from minus 2w to plus 2w, and 1 pi is already there, so this pi will be cancelled, so this is thing we are getting. Now it is multiplied by cos 10 omega, so this spectrum by modulation property will shift to 10 omega on both sides, so this will be 10 omega minus 10 omega, and this will be 12 omega 8 omega, and then this will be like minus 8 omega minus 12 omega, and width is w. Okay, w by 2 because width is out after modulation. And similarly input is a cos omega naught t, so it has Fourier transform a pi delta omega plus omega equal delta omega minus omega. So 10 cos 10.5 omega t has Fourier transform 10 pi delta omega plus 10.5 omega plus delta omega minus 10.5 omega. So if you plot it, it's basically two impulses at 10.5 omega and minus 10.5 omega. Now to find the output we just need to sample the value at this point. So how do you find this value? So you can see that when I move a distance of 2 omega, I get a height of omega by 2. So when I move distance 1.5 omega, then you can see after cross multiplying, because it is linear function, I can get this thing as 1.5 omega into omega by 2 divided by 2 omega. So this is 3.8 omega. Okay, so now since it is a sinusoidal inputs out and it is a LTS system, so output will also be sinusoidal, and here I will use the relation that output for sinusoidal input of frequency omega node is system gain at omega node into input sinusoid. Now system gain at omega node means h omega at omega is equal to 10.5 omega node into the input, which is 10 cos 10.5 omega t, and this thing I have found out as 3 by 8 omega. So final answer is 3 by 8 omega into 10 cos 10.5 omega, which is 15 omega by 4 into cos 10.5 omega t. Okay, which is option number A. So we need to take first frequency response of this thing, then we need to pass it. So this is impulse, so it will sample this value, which is 3 omega by 8, and then I have used this LTS system fact that output for a sinusoidal input is equal to system gain and omega node, which is h omega at omega is equal to 10.5 omega node, because the frequency of input signal is what 10.5 omega into the original input, which is 10 cos 10.5 omega. Okay, so when you multiply it, I get the answer. So these are all the 9 questions. Thank you.